Good day, everyone. Today we will continue finishing the revision sheet. Okay, we'll start from problem number 35. 25 volunteers will wear one of 6 blue. Okay, so if you find a problem like this, try to isolate each one. So it's 6 blue, 7 green, 8 yellow, and 4 red aprons during an upcoming food drive. If the aprons are assigned randomly, what is the probability that the volunteers is assigned an apron that is not green? So we want to check what is the probability of not green. We have to wait to solve this question. First, not means 1 minus. Green, so 1 minus the probability of green. Probability of green here, green is 7. So it's 7. And the total number of all colors, 6 plus 7, 13 plus 8, 21 plus 4, 25. So the denominator is supposed to be 25. Green represents 7, so it will be 7 over 25. As we said before, it's part over whole. 1 minus 7 over 25 equal, we can consider 1 as 25 over 25 minus 7 over 25, so it's equal 18 over 25, which is D. So the answer is D. Another way to solve this problem is not green means it may be blue or yellow or red. Add them together, you will find them 18 over 25. Both are right way. So not means 1 minus the probability of the color, or you can choose the others. Okay? Okay. Second, Miguel is preparing the probabilities of 2 spinners. Which of the following statements is true? Select all that apply. Don't forget, select all that apply. That means we may have more than one answer. You have to choose all. And don't choose the wrong answer because it will delete right answer. Okay? Okay. First, it's twice as likely that pointer A will land on 1 as compared to pointer P. Twicely, that means multiply 2. Okay, so let's get the probability on spinner 1. Spinner 1, P of 1 on spinner A. Okay, equal 1 appears how many times? 1, 2, 3. 3 over and all 8, so it's 3 over 8. Let's calculate it on B. On B, 1 appears 1 time. So probability of 1 on spinner P equals 1 over 4, which is not equal, not twice. It's not twice. Okay, so it's wrong. We can't choose it. The probability that the pointer B will land on an even number is half. P, okay. Even number on B, it may be 2 or 4. All numbers are 4, so the denominator is 4. Even number is 2, 2 over 4, which is half, which is right, yes. B of even equals 2 over 4 equal 1 over 2, so it's right, we can choose it. Sorry, this belongs to this one, so yes, that's right. Okay, number 3, the probability that pointer A will land on 1 is 3 over 8. We already calculated before. 1, 1, 2, 3, 3 times, so it's 3 over 8, it's right. Okay. Spinner A is a fair spinner. Fair means it gives equal chance for each one. So it's equal for, not equal for 1. Only appears 3 times, and 2 appears 3 times, but 3 1 time, 4 1 time, so it's unfair. Unfair. It's unfair, not fair. So we will not choose it. Last one, it is equally likely that the pointer A will land on an odd number as compared to pointer 2. So he means in pointer A, it will appear land on odd numbers. So odd numbers are 1, 1, 1, and 3. So it's 4 over 8. So P of odd at spinner A, B odd equals 4 over 8, which is equal 1 over 2. At B, spinner B, even numbers are, odd numbers are 1 and 3. So at spinner B, B of odd equal 1 and 3. So it's 2 over 4, which is equal 1 over 2. So they are equal, so we will check it. Okay, so the answer is 2, 3, 5. Okay. 37. Fill the blanks. Okay. Probability of an event equal number of favorable outcome, which is the part, over total number of outcomes. Of outcomes. All numbers which outcomes will be in the denominator. Okay, when we want to expect or predicate another probability without doing it exactly, how to predicate it? So to predicate, if you find problem talking about predicate, okay, and something we don't know, maybe we said that what do you expect if we flip the coin 100 times? In this case, we use proportional to equal ratio. So first one, favorable, which is part over all numbers of outcomes. Second one is what he asked about, what you expect. If the total number is kaza, it will give me a number. So you have to find x. X here is what? The winners. Winners. Oh, number of winners. Okay. So number of winners or contestants. So number of winners of contestants. Okay. So we can expect the number of winners if we know the number of favorable outcomes over the total. We'll take some examples about it. Sanji throws an 8-sided solid faces numbered from 1 to 8. In this case, I advise you to do the following. You must write the sample space first. So S equal from 1 to 8, 1, 2, 3, 4, 5, 6, 7, and 8. Okay? To easy calculate. Select all that apply. Okay, probability of even number is 1 over 8. Even numbers here are 2, 4, 6, 8. So it's 4. Over all numbers is 8. So it's 4 over 8, which is equal 1 over 2. So first one is wrong. Is wrong. We will not check it. Second, 1, 2, 3, 4, 5, 6. We'll consider it as it is. Number 2. Be multiple of 3. What is the meaning of multiple of 3? Number which exists in times table of 3. What times 3 gives you this number? 3 is a multiple of 3. Because 1 of times 3 equals 3. 6 and so on. That's it. This is the only two multiple of 3. So which is equal 2 over 8. Yes? 2 over 8 equal divided by 2 equal 1 divided by 2 equal 4. So yes, it's right. It's equal 1 over 4. Number 3, be odd number equal half. Let's count the odd numbers. Odd 1, 2, 3, 4. Yes, 4 over 8. So it's 4 over 8, which is equal 1 over 2. So it's right. Number 4, a number less than 8. How many numbers less than 8 and probability of them? Actually, it's 7. Less than 8 from 7 to 1. 1, 2, 3, 4, 5, 6, 7. So probability here equal 7 over 8. Not 1, so we'll not check it. Factors of, number 5, factors of 24. What is the meaning of factor of 24? Factor of 24 actually, okay. Factor of 24 is what times what gives us 24. This is called the factor of 24. So let's calculate it. First, factors of 24, 1 times 24. Yes, so 24, 1 and 24. 1 times 24, 24. So 1 and 24 are two factors. 24 2 can be written as 2 times 12. So 2 and 12. 24 bar also can be written as 4 multiply 6. Also it can be written as 24 over will be 3 multiply 8. Okay, what is the factors included in our example here? 8, 3, 6, 4, 2, and 1. So the factors are 1, 2, 3, 4, 5, 6. So it's 6 over 8. But he asked for 3 over 4. Okay, simplify. Divided 2, it will be 3 over 4. So which is right. So we will check it. Last one, probability of number 9. And I don't have any 9. So it's 0 over 8. So equals 0. It's right. I hope you understand it well. Next. The table shows that the outcomes of rolling 2-number cube. If you roll 2-number cube, first one you can consider the first one as this row, second one as this column. Then we make this grid or this table, okay, which represent all possible outcomes. How to know the number of possible outcomes without counting it? I have 6 results here and 6 results here, multiply them together, so the whole results are 36. So the denominator always 36. So he asked for what is the theoretical probability of rolling a product greater than 10. Theoretical means we didn't do it in actual life. We just do it on paper. We try to expect what should happen over papers only. We didn't make it in real life. Okay, this means theoretical. Okay, so theoretically, if I need product of the two number are greater than 10, so 1 times 1, 1. It's not right. What is the greater than 10? Start from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. 13, 14, 15, 16, 17. Yes, I have 17 over 36. Okay, if AP rolls 2-number cube 100 times, if we did the same as 100 times, about how many times would you expect a product greater than 10? So I will predicate. I will expect what will happen in the future. So it's proportional to equal ratio here and ratio here. First one represents numbers of theoretical ratio, which is equal 17 over 36. Next, in the second part, I have what? I have the number of 100. He said 100 times. Okay, if he roll it 100 times, what do you think about the product will be greater than 10? Is it bigger or smaller or something else? I don't know, so I will call it x. By doing cross multiplication, so x equal, what with x is down, so 36 up, 17 multiply 100, which is equal approximately 47. Okay. So if you want to predicate, you have data now, and want to predicate what should happen or what will happen, it's called theoretical. And theoretical equals, we will do what? Equal fraction, to expect what should be done. Okay? Next. 40. Samira is playing a game with the spinner. Spinner included what? This spinner. And as you see, some letters are repeated, like A, J, only, and the others are different. So it's unfair spinner. We call it unfair spinner. What is the theoretical probability that the pointer will land on a section labeled with the letter A on a given spin? Total number of spinner, total number of outcomes are 1, 2, 3, 4, 5 times 2 is 10. So it's 10 over 10. Probability of land on the letter A, how many letters A? 1, 2. So it's 2 over 10, which is equal 1 over 5. That's it. Okay. B. Predicate. Take care about it. Predicate. So to make a prediction, we'll take the fraction equal what predicate? That's what we will do. How many times the pointer will land on the section labeled with the letter A after 300 spinner? 300 letter A. I don't know how much exactly it will. 300 is too much number. Can we calculate it in our class? Theoretically, yes, put x here. So x equals 300 divided 5 equals 60 times. Okay. Next. Twelve-sided solid face. As I told you before, if you have numbers or something like this, it's easy to write the sample space first, which included 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Why we use 12? Because he said that this is 12-sided solid is rolled 180 times. How many times? First one, number 8. Find the probability of rolling number greater than 5. Let's count them. All of them are 12. So the denominator is supposed to be 12. Okay? And then probability of greater than 5. So it will be 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7. So it's 7 over 12. Okay? If the 12-sided solid rolled 180 times, we try to expect how many times would you expect either a 3 or 9 or 11 be rolled? 3, 9, 11 appear only one time here. 3, 9, 11. So the probability of it equal 3 over 12. You want to predicate what should happen if we do it for 180 times. So put x here and x equal divided 12 and up 3 times 180 equals whatever. Divided 3 equal, it will be about 3. I think we have the last answer. Divided 3 equal 4, divided 4 equal 1, 180 divided 4, 45. So it's 45. 45 times. It may appear one of them. One of these numbers, 3 or 9 or 11. Okay. 42. Camel rolls 2 number cubes together and records the sum. If she does this 180 times, how many times should be expected to the sum to be 7? Sum to be rolled 2 times, as I told you before, we make 2 rows. 2 rows, 1 row and 1 column. And then see what he wants. He wants the sum. So sum is 7. So he needs the sum to be 7. How many sum 7? It's 1 plus 6, 2 plus 5, 3 plus 4, 4 plus 3, 5 plus 2, and 6. So how many 7? 1, 2, 3, 4, 5, 6. So it's 7, 6, 7. So it's 6. Over what? As I told you, running, so it's 6 multiplied 6 equal 36 over 36, which is equal divided 6 equal 1 divided 6 equal 6, so 1 over 6. That's it. Okay. 43. How is experimental probability different from theoretical probability? Experimental probability is represent actual event, it's happened. And the probability of theoretical probability expect or predicate. Okay? So you can expect, which is theoretical, and for the experimental, which is in real life. It happened in real. Okay? 44. Jessica records the number of winners at Dunk a Teacher booth at the town fair as shown in the table. If there are 750 contestants on Monday, how many should Jessica expect to dunk a teacher? Let's calculate the probability here of winners. Okay? Winners here equal, if we add them together, all contestants are 1,000. Okay? And the winners are 120. So probability of winner B1 equal 120 divided 1,000. 0 is 0, divided 2 equals 6, divided 2 equal 50, divided 2 equal 25, divided 2 equals 3, so it's 3 over 25. We can write it by percent by multiplying it by 100. If we multiply by 100, we'll give you the percent. So the percent equal a number. Now we know the expected number here, which is 3 over 25. What if on Monday, the contestants are 750? How many one can win? Actually, we'll do the following. So after we find it, first it's 3 over 25. We will equal it by, the denominator is total, so 750, met x here, so x equal 3 times 750 divided 25, which is equal, equals what? Multiply 25, so just calculate it, we'll find x, okay? So this is the expected number. How to expect a number. Last of this page, in a bag of 25 marbles, so total number is 25, so the denominator is supposed to be what? 25. So over 25 to calculate the probability of each one. Over 25, over 25, over 25. Okay? Let's calculate each one of them. I have 5 red, so 5 over 25. 7 blue, so it's 7 over 25. 10 green, it's 10 over 25. And 3 yellow, 3 over 25. This is what, this is called theoretical. You give me a number, and I try to write it as a probability or prediction. Want to predict it. Okay. But in experimental, which is actual, we found the following results. The sum of them is, when we repeated more than one time, found the sum is 50. So it's different here. So first one, red was 5 over 25, and second one, in the experimental probability, red equal 18 over 100. Multiply it by 100 and both by 100 to get the percent. Okay, and compare them. Also the same for blue. It will be 10 over 50. And for green, it's 15 over 50. And for 3, for yellow, it's 7 over 50. We need to calculate each one and see the difference. We'll find the closest difference is yellow, which is the right answer. Thank you for listening. It's nice to be with you in the first revision of math. Okay, see you, bye.